Assalamu alaikum everyone. Welcome to the special interest group session on cloud technologies. This is seventh in a series of sessions that we have been having. We are conducting these sessions every week. The other areas that you will find in your emails include AI, IoT, as well as cybersecurity. Today we'll be having with us Asim Ehsan, who is our uh, networks development veteran. He has 15 years of experience, and he'll be sharing with you today about OpenShift technologies. Previously, we had a session where we introduced the concept of microservices, containerization, Kubernetes, Dockers. Today, Asim will be giving a brief recap of that just to build up to today's topic, and then Asim will be explaining to you about DevOps and leading to OpenShift. Uh, these sessions are recorded, so in case you have to leave earlier, you will have the opportunity to listen in once they are published on YouTube as well as our sites. Uh, I'm joined here by Ahmed Jafar, who is our academic outreach coordinator. Ahmed Jafar will be sharing our email address in the chat window. So if you have any questions or queries, you're welcome to reach out to us. Also, sort of some housekeeping rules. We do have a question and answer session at the end. So if you have any comments or queries or you want to reach out to the speaker, please make use of that time slot. I hope you all can see my screen. I would take that as a yes. Uh, So this is the agenda for today's talk. We have first with us Asim Ehsan, who will be sharing with you about OpenShift, and then we'll have the general discussion session, which I just mentioned. With this, I'll hand it over to Asim Ehsan. Over to you.
Yes, thank you, Hashim. And just give me a minute, let me share my screen and we could start. Can you see my screen?
Yes, I can.
Okay. Should I start now?
G, please.
Okay.
And
So
you
to
can go
talk,
mode.
okay. So today we have to talk about the OpenShift technology, that is the most emerging DevOps tool that is very in the market, and lots of companies are using this tool and adopting this tool to automate their development process. So today we will just look a quick overview about the OpenShift, what are the components, how it is working. So today's agenda point is OpenShift from Red Hat IBM. Since Red Hat has been acquired by IBM, and so so basically OpenShift is a product of Red Hat. So that's why it is now under the control of IBM. And then we have a quick overview of containerization and microservices. We had this in our meeting, in our last meeting, in which we discussed about the microservices. This is just an overview. Then DevOps components and why OpenShift for DevOps, for developers and operations. And if you wanted to master yourself in DevOps, what is the roadmap of this one? So let's start the evolution of development and deployment. So basically, this is a quick overview that what was the development process in it is, and then how the things evolve from in 90s. So that initially it was the application architecture was monolithic on a single server, everything, and we have for every application we are deploying a separate server, and each server holds the database and application logic and everything. and that is a center point of failure and bottleneck. And the development process was also quite slow due to the resources limitation. Then in after 90s, in 2 decades, from 90s to 2010, the virtualization was quite in, where VMware, Citrix, Hyper-V, KVM. So these are the top leading vendors get into the market, and they start virtualization, and the same hardware could hold multiple number of servers, and you can deploy multiple number of application on a single server, and that make the application deployment agile quite faster as compared to waterfall. And then after 2010, the concept of microservices has been arrived, and the newer term of DevOps for the development of application has been introduced. And this DevOps basically is based on the microservices. We discussed this microservice concept in detail, and what happened, the microservices basically did the division of your application components into small parts, and each component run independently in the form of container, not in the form of virtual machine, not in the form of a physical server. So that containers hold a small business logic of the application. If that container goes down, your application will still remain up. And these microservices containers could orchestrate by different tools, that is Kubernetes, and can hold the unlimited number of users that we cannot expect at different time of the working hours. So this is the latest technology, and this microservices also made our life easy in the process of development and the whole life cycle of the application. Okay, so then just this is a trend about the containerization and Kubernetes. Kubernetes is basically a tool that helps us to orchestrate our containerization based application. So orchestration, administration, a lot of other stuff. So it was in 2017, it was just 1.124 billion dollar of industry, and you can see here it is quickly growing, and in 2022 it is expected up to more than 4 billion of industry, as all our legacy applications are quickly shifting over to containerized application. And if we talk about the tools that are in market to manage the containerized based application, so there is an OpenShift, you can see there is Shell Script, there is Mesos, Cloud Foundry. So these all Amazon is this is Amazon AWS, Docker Swarm, Google Container Engine. So these are the different engine, and on top of the list is Kubernetes. You can see 69% of the applications are on the cloud are developed on deployed on Kubernetes. So what are the basically runtime platform? We have these three components. The core, these are the core components that are leading this whole industry. And the first one is Docker. This is the base. This is the core engine. And Kubernetes is basically a tool that is to manage the Docker and for the orchestration and the load balancing and the plenty of stuff, and failover and load balancing and auto scaling, and then over the Kubernetes, OpenShift has been evolved with the time by Red Hat. So these are the main components that are in the market to in the field of you can say. Yeah, can you hear me? Yeah, IP.
Yes.
Okay, okay. So Okay, so let me do a full screen. Okay, so the next slide is basically the concept about the DevOps components. This is a detailed work flow chart of DevOps. How DevOps evolve and what are the components involved. How DevOps made our life quite faster in term of development and deployment and plenty of other stuff. So let's start from the right side. You can see here there is a system administrator sitting on here, and system administrator, and there is a monitoring administrator monitoring different servers and components and applications running on cloud or on-prem. And Ansible is a tool that is known as the language of your DevOps, I mean language of infrastructure. So you can, if you want to build uh, some infrastructure over the server, so you can code that infrastructure. Once you have the pain to code it, and the next time wherever you have to deploy that code, you have a just single file of Ansible playbook, and that Ansible playbook can deploy the whole infrastructure in just limited time. So Ansible is one of the most powerful tool in the field of DevOps, used by system administrator uh, to orchestrate your infrastructure and to deploy your infrastructure from scratch. So if you have any question, you can ask in between the our discussion. You can stop me and you can ask the question about anything that I am discussing here. So these are the main player who has to deploy all this infrastructure. So let's start from the developers. This is a team of developers sitting here, and they are working on the different tools, different development tools, just like PHP, Java, or Python, or it could be your Node.js or .NET, or any type of application, mostly many type of application tool that is in the market. So developers are just busy in their work. They are writing their code. They have some requirements from the customer care. I mean, customer care told that the application in the development process need some new updates. So the developers are working on it, or there could be a new requirement of new software development requirement from the company, that have we have a new project and we have to work on it. So developers start working. So what developers are doing, they are just writing the code what they know, and they are just writing the code, testing it, very initial stage on of testing on their own laptop or desktop or mobile devices, and then they just put the code after their satisfaction into the Git. So Git, you know that Git is a centralized repository that can hold your code, and it can do the versioning of your application. Mean what first, for example, there is an application. There was an application developed 2010, and at that time its version was 1.1, and now we have version 11.15. So all different stages of the development are committed in the Git. So code is pushed by developers into the Git. So in the field of DevOps, developers just have to push their code. They just have to get the request that this is the requirement, make the development of that code, write down the code and put that code into the Git. So this is the total work for the developers. Rest, after pushing the code into the Git, and obviously Git will have different projects, and each project will have its own repository. So system administrators deployed a Jenkins. Jenkins is basically the core of this whole DevOps. Jenkins is a so powerful tool that can perform, that can build your complete CI/CD pipeline, continuous integration, continuous delivery pipeline. And after this slide, you will have the complete idea how CI/CD is working, how things are developing in quite faster way. So Jenkins is basically deployed by the system administrator either by using Ansible or directly. So Jenkins server is there. It could be on the cloud or it could be on your on-prem server. So you told Jenkins that these repositories are available in the Git, X number of repositories. You can have number of projects at the same time, different developers working on different projects at the same time. And Git, Jenkins can pull all those different projects from the Git and Jenkins then, after pulling that code, will inspect the code by Sonar Cube. Sonar Cube is basically a tool, an open source tool that is integratable with the Jenkins. There are plenty of other tools, but Sonar Cube is one of the tool that is in use to test the different things in the code, just like there are different vulnerabilities standards have been defined. I mean this type of API should be in the application. This these functions are deprecated should not be in the application, and these are the so such things are are verified by the SonarQube from the code. And if there is a bad logic, there is a memory leak in the code, so SonarQube will reflect you back that that this should be corrected. It will give you the suggestions. And if there is a bad code developed by a non-professional developer, and the simple business logic that you can write in 3 line of code, and that code has been written in 50 or 100 lines, so SonarQube will suggest you that you can reduce the line of code. So if you have less number line of codes, it's mean less CPU and memory consumption while executing this code. So after passing the code from SonarQube, Maven is a tool. It's also an open source tool that is used to make the build of that code. If you are working in a Java environment, you need to build your code in the form of jar. So there are different development language, programming language that need their own type of build. So Maven will then build its type of application. So so now if SonarQube pass it, then the Jenkins hand over it to Maven. Maven give us a final build of the application, and then Jenkins use that build to generate a container. So Jenkins write a Docker file. That Docker file can be supplied by the system administrator to the Jenkins that use this Docker file. Docker file is basically a piece of code in which it is written that what should be the specification of the container. So container is basically in the first step, it is an image. So from image, you can spin up your container running copy. And in our last session about microservices, we had a detailed practical lab where I showed you that how you can quickly spin up your container. So this is the same way. The code, build code is burned into the image. For example, this is a Java application, and Java application can run over Tomcat or over JBoss or over Wildfly. So it is decided by the internal internally by the system administrator and developers that we have to use Tomcat or JBoss or Wildfly. So that image will be used for specific code that we developed and put our build in this code. So, and then it could, when you will run it, it will take a form of container. So now we just have the image. So image will then be pulled by Jenkins to Docker Hub. Docker Hub is a centralized repository on the internet where you can dump your different images of different applications. So, for example, you develop a simple application A. So that application A build into the form of Docker image, and that has been pushed into the Docker Hub. It's your decision either you wanted to make it public or only for your own use. So once the application in the form of image is deployed into the Docker Hub, so Docker Hub now is a centralized repository, and everybody that have the access to that repository can pull that image, can pull that image in their own environment and can deploy in the form of container that same like that we did in our last session. So Kubernetes is basically a tool that I explained you that it can run your Docker images, can manage it, can orchestrate it, can uh, can do load balancing and failover. So Kubernetes is a huge product that can do a lot of stuff to manage your application. So this system administrator push, write some YAML files. YAML basically Kubernetes language is in YAML. So YAML file holds some information that pull this Docker Hub and run it in this format and expose it to the public on the internet, and these ports should be exposed. So such type of things are written in a file, and there is a deployment of the application. So first deployment stage is for the of the application that was starting from the developer's desk to in the form of image and Docker Hub and then Kubernetes. That is a web interface of that application. That could be a web interface, uh, and uh, and that application is deployed for the use of quality assurance team, QA team. So quality assurance team will internally look this application, either this application is good as per the requirement of the customer, and will find any bugs, any any security vulnerabilities, any issues, any memory leaks that have not been identified by SnarCube. SnarCube is just looking your syntax and some standards, but the requirement of the application cannot of the customer, the application requirement cannot be verified by SonarQube. It is only the humans, by the humans, that can look each and every requirement, can valid look the application, can do the load testing of the application. Load testing is not an issue, just the business logic should be fine and the proper UI should be fine. And this quality assurance team will then mark a Q quality assurance tag that this application is good. Then this application will be pushed into the production environment with the approval of quality assurance team. Mean you can see, look here, prod app development of deployment after QA approval. But if QA team found any issue, any bug, any limitation of the application, they will straightforward report to the developers. Mean this application we found these type of limitation, and again the developers will do the development, and again they will push the code. Again the SonarQube and Maven, and again the new image will be put into the Docker Hub, and it will deploy by the YAML file in the Kubernetes, a new the QA application will be available, and there is a system in the Jenkins that will automatically email to the relevant department QA that I deployed the QA application on this URL. Go ahead, use it. So then again the QA team will validate it. Again founds any issue. Again it will refer to the development team, and that this process will continue until unless we are not able to make our application as per our own requirement. So since there, suppose we reach with the time that our application is now in the healthy state, and we are good with this application. So a QA team approve it. So after approval, the application, same application, container image, was deployed for the production on the Kubernetes environment, and that production environment have its own URL, and Jenkins email the end user, that is your customer for which you are developing your application, that your application is ready for use. You can use this is a newer version. So use this URL and use your application. In this whole environment, I just drawed the development of QA and production environment. You can make number of pipelines, like you can make the pipeline just like first stage is QA, then user acceptance testing, or before the user acceptance testing, it could be the security testing, mean application is not vulnerable, and then the UAT, user acceptance, and then the production. So these all types of pipeline can be built. You can build with the help of this Jenkins and Kubernetes, and these are all the components that are in play. And now user is using the application, user have some experience, user is happy with the application. Suddenly user found that I need this new business logic in my application. I need this new feature. So that user will write an email or call to customer care center that I need this feature. I have an SLA with you, and please develop this new feature. And then the customer care will talk internally that either we have to. This is the scope of work. This is a scope of SLA we have with this customer. Either we could do it or not. And after the approval from certain department, that requirement will be sent to your developers, and again the developers will start making the development process, and again this whole life cycle will be in the process, and this is a continually cycle that will be in your production environment. So, so, so user can also report some bug. There could be a chance that QA team have not verified its application due to some reasons, and user reported. And in that case, also the user will report that things to the customer care and to the developers. So, any question about this whole infrastructure that we discussed? Okay. So are you good?
I think we should proceed.
Okay. So the next thing is why customer choose OpenShift if we have this whole infrastructure. So what OpenShift did? OpenShift is basically a tool developed by Red Hat. What Red Hat did? Red Hat have some physical server or virtual server or private server, the public on the public cloud. They have some virtual server. They deployed Red Hat Enterprise Linux Core OS. This is a specific operating system variant of Red Hat Core OS, for specially designed for the containerization based application deployment. So these infrastructure, different virtual servers or physical servers installed by Red Hat Core OS, then you then deployed a Kubernetes over these environment. And over the Kubernetes, basically, by if you are directly working with the Kubernetes, it is totally a command line based tool. You need to work in the YML file, and there is not no monitoring tool attached with it. But what Red Hat did, Red Hat add plenty of stuff with uh, this over this Kubernetes environment, and just like Grafana, Elasticsearch, these are the different tools that are used to monitor the application. And if you look into the previous slide, the monitoring was done by different other tools for this whole infrastructure. So this whole infrastructure have been captured into the OpenShift. So OpenShift provide us the Jenkins, OpenShift provide us the connectivity with the GitHub and the different tools that can validate our code, can build our CI/CD pipeline, different automation operations, and the variety uh, of applications that just like PHP, Node.js, Java, Python, Ruby. So these are the different tools that are mostly in use by by the developers, and so all these functionalities are bundled in a single package in the form of OpenShift, and it also gave us a web interface, so that with the web interface we know how many CPUs and RAMs are storage is occupied, how many resources we need to add in our infrastructure, and everything is on your dashboard. So the things that system administrator and monitoring team done independently, it is combined in a single. It is combined in this single framework known as OpenShift. So nowadays the OpenShift version 4 is 4.5, and I think 4.6 is in the market. So, so this was the reason why OpenShift leverage in the market and getting the space as compared to Kubernetes. So, roadmap to OpenShift, if you wanted to be a master of OpenShift. So this is a complete roadmap. Uh, just like your starting point, you should know monolithic and microservices, the concept initially, and then you should be able to work on the virtual machines and the Docker, and you should know what is the difference in a virtual machine and a container. So, and then you should know, you should have some hands-on on the Docker command line, containers option. These are the uh, different Podman, CRIO, different tools that can run your containers, but Docker is the top leading one. So you should know about the Docker, or and then you should have a hands-on on building the image, how we can build our image, how we can spin our container from some image, and this is a diagram that showed us that uh, images are available on the Docker Hub repository, and you pull it, the image, and run the container according to your requirement. And then this is the Docker installation process, building the containers, building your application manually. That will do automatically by the Jenkins later on. And then Docker containers, image Docker Hub, there is this image is built. Now you can create your own containers from those images. And the next is Docker container image and Docker Hub mean you should have a hands-on on the utilize command line of the Docker, and the networking part of the Docker mean how you can expose your application running in the Docker in the microservices format, how you can expose your services to public access. So it is, there are different concepts like bridging, host, and overlay, and MAC VLAN. So it is a detailed uh, uh, curriculum that holds this information. And then the centralized Docker repository, everything, whenever you run a container, basically by default, it is ephemeral storage. It is not permanent. So if you, to make it permanent with the production and killing of new container, your data should retain on a centralized location, and then you should know how your container can save the data at a centralized location. And then Docker Compose is basically a tool that can do plenty of stuff for the building of your container images. That, just like, let me go back to this slide, that in this state Jenkins use the code to generate our image. So this is the location where we use Docker Compose files to YML files to create our container as per our own requirement. And then the Kubernetes started. I mean, now you are good with your container work, and you should know this, how your, what is Kubernetes, how it can run, it can spin up your containers, it can orchestrate, it can do a load balancing, it can do a self-healing. You have number of servers, hundreds of servers running under Kubernetes environment. One server goes down, what happened? It should shift your running containers to the other hosting. So this is the containers orchestration by Kubernetes, and then Kubernetes architecture. This is again inside story of Kubernetes. Kubernetes objects. Basically, whenever you deploy a container inside the Kubernetes environment in the form, so this is known as pod. So inside the pod, you are running different containers. So each pod is representing a single component of your application. One pod could hold your database, one pod could hold your front-end application, one pod can hold your back-end application or some other business logic. And each pod, those all pods are interconnected with each other with some networking defined by Kubernetes. So Kubernetes installation option, there are different automation tools that can do on your own deployment of Kubernetes. And then this is the Kubernetes installation again. This is just a small Kubernetes deployment. There is a master node, there are two compute node. You can expand your master node and compute node to avoid any further failures. And the pod management, you should know how you can write down your YML files for your deployments. And Kubernetes networking, load balancing, and how you can expose your application to public environment. I mean, these are your pods. There is a service that is taking care of these pods, and that service expose your application to public internet securely. And then the storage concept of your, I mean, the users are writing their data. There are databases running, and if that container goes down, that data should be retained, and that should be reachable to the newer container that are spinning up. So this is the complete infrastructure and the concepts of centralized storage management. And then the beauty of OpenShift is you can work with RBAC. This is the complete role-based access control. I mean, different projects, different companies' projects are in your same Kubernetes environment, and you have to give access to different users, to different application, and different administrators to different application deployment process. So it is also manageable by Kubernetes and OpenShift. And then you can go ahead with your Kubernetes certification program. So this was about the Kubernetes, and same is the roadmap almost with your OpenShift, but OpenShift just have additional steps, just like the management of your graphs and some additional dashboards that are provided by OpenShift. So this is the end of our presentation. So Hashim, now it's over to you.
Thank you, Asim. Excellent presentation, and yes, thank you very much. And I think we are going to be continuing this series of sessions on microservices, Kubernetes, and OpenShift. So I would request if anybody is interested, so keep checking your emails. Um, if there are any questions or comments, now is the time. You can unmute and ask Asim. If there are no questions, so we can then move on. We normally have a round of introductions, and we start from our participant list. So I'll speak your name, and if you are interested to share with the audience as to what you do and your interest in OpenShift or containerization, we'll be happy to hear from you. The first person I see is Asad Ahmed Ansari. Would you care to unmute and share, please?
Thank you, Hashim, for meeting me and giving me the opportunity. Currently, I'm pursuing. I'm audible to you.
Yes.
Currently, I'm pursuing a postgraduate program from FAST Karachi, and my majors are in computer network and security. Currently, we are working on software-defined network, so this would be beneficial in my academic procedures. So this was the whole thing I want to share. Thank you.
Thank you, Asad. Next, we have Dr. Hassan Jamil.
My name is Dr. Asim. I'm just interested in the topic, so to be honest, a lot of things are new for me. Thank you. My name is Dr. Hassan Emin. I'm not sure if there may be problems on my mic. Can you hear me now?
It's a little better, yes.
So I'm just interested in the topic, and I just got the basic knowledge. To be honest, I was many things new for me in this topic. Thank you.
Thank you, Doctor. Next, we have Navera Sahar. Next, we have Syed Ahmed Saad Zadi. All right, Ji. Thank you very much for joining, and we look forward to have you in our next sessions. Cloud Pay next session is going to be 4 weeks from now. Immediately next week, we are going to have a session on IoT technologies. So if you're interested, keep checking your emails. Jafar will be reaching out to you with more information on the next session. Thanks again for joining and have a nice evening. Assalamu alaikum.